Hey guys, this is Mr. Grice for Algebra 2, Unit 3, Review A, video number 2. Sorry guys, I already did this page. Well, go back and watch it. It was video number 1. Okay, so on the back now, once again, show every step, write answers on the lines, and let's get to it. Now, we're talking about absolute value equations, and to write our final answer in set notation, especially in number 11 and number 12 when we get down there. So let's get to it. Now, just a reminder, first we want to get the absolute value by itself, okay? So when the absolute value equals a positive number, we are going to have two answers. If the absolute value equals 0, we are going to have one answer. And if the absolute value, when it's all by itself, equals a negative, remember, that is no solution. Okay? But the key thing is the absolute value has to be by itself. So for number 8, the absolute value is not by itself yet, so I can't say no solution. I have to wait for the absolute value to be by itself. So I have to follow SADMAP. We get the absolute value of 12 minus 7x equals negative 19. And now the absolute value is by itself. It can't equal a negative. So since it can't equal a negative, our answer is no solution. Number 9. The absolute value is not by itself. So I can't add 4 plus 5 because the 5 is being multiplied right now. So I have to subtract the 4 to both sides. We get 5 times the absolute value of x plus 6 equaling 0. Absolute value is not by itself yet. We just said that that's multiplication. So to get rid of multiplication, I need to divide. So we have the absolute value of x plus 6 equaling 0. And now that my absolute value is by itself, it equals 0. That means there's going to be one solution. So I just do x plus 6 equals 0. And now I solve. Subtract 6 to both sides. And we get that x equals negative 6. All right, number 10. Get the absolute value by itself. You can't say no solution. Remember, not yet. So I add 4 to both sides. We have negative 22 plus 4, which is negative 18. Okay, the absolute value is not by itself. That's multiplication. So to get rid of multiplication, I divide both sides by negative 3. And I have the absolute value of 1 plus 2x equal negative 18 divided by negative 3 is a positive 6. So the absolute values by itself, it equals a positive, so that means there are two solutions. I set 1 plus 2x equal to negative 6, and 1 plus 2x equal to positive 6. Okay, so I had to break it down to two answers. Okay, and then I solve. And the nice thing about solving it, you're doing the same thing. I subtract 1 to both sides over here. Hey, guess what? I'm going to subtract 1 to both sides over there as well. You just have to be careful because your answers are going to be different. -6 minus 1 is -7. 6 minus 1 is 5. To get the x by itself, I divide by 2. And I get x equals, I want the fraction for both of them. Yeah, it's okay, you can get fractions. Okay, so that means that x can equal -7/2, or it could equal 5/2. How am I doing so far? Am I getting them right? I hope so. The answers are on the bottom. Do you notice that? Okay. So when we're solving each absolute value inequality, this is where we're going to write our answers in interval notation. Okay? Just like before, we need to get the absolute value by itself. Okay? So to get the absolute value by itself, I have to subtract 1 to both sides. And we get the absolute value of 7 plus 7x is less than or equal to 21. Now that the absolute value is by itself, I can figure out how to set this up. And it's not the 21, I'm sorry, it's not the 21 I'm looking at. I'm looking at the symbol that is less than. Do you guys remember how we said that? So if it's less, we say that it's less than, and it's greater. Okay, so if it's less and, this is how we set it up. Okay, we set it up to -21 is less than or equal to 7 plus 7x, which is less than or equal to 21. Okay, what I want you to notice is that our inequalities stayed the same. I'm using less than or equal to both times. The thing that changed is 21. I set it up to a positive 21 and a negative 21. Okay, and now we solve. We solve using SADMAP. So I have to subtract 7 to all three sides. -21 minus 7 is -28, less than or equal to 7x, which is less than or equal to 14. To get the x by itself, I have to divide all three sides by 7, and then we get -4 is less than or equal to x, which is less than or equal to 2. Okay? This is our answer. Sorry, I don't like how I drew that. There we go. That looks much nicer. Now I'm going to take that and I'm going to graph it. Okay? So I'm going to put 0 in the middle-ish. 1, 2, 3, 4, -1, -2, -3, -4. Don't just write it, okay? I want you to notice that the x is in the middle, so I'm going to shade the middle. At -4, we are closed, and at 2, I'm closed, and then I just said where to shade. Okay? And then writing that in interval notation, I'm closed at -4, and then I go to 2. All right. Next one, number 12. We got to get the absolute value by itself. So to do that, I need to cancel the addition first. I have -6 times the absolute value of 4x minus 6 is less than -84. The absolute value is not by itself yet, so I need to divide both sides by -6. So I have the absolute value of 4x minus 6. I divided by a negative, so I have to flip the sign. And then -84 divided by -6 is a +14. Okay? So now when I'm looking at this, that tells me that it's greater. Okay? So if it's greater, this is how we set it up. Okay? You have the 4x minus 6 and the 4x minus 6. We good so far? Good. One of them stays exactly the same, greater than 14. Now it's our other one that we have to switch it, because when it's greater, that's when there's the break in between. So I need the inequalities to be pointing at different directions, and then I set it to a -14. And this is what we solve. Okay, I'm just a little crazy, so I'm going to move this so it's more in the middle. Yes, I know I'm crazy. That's all right. And now we solve. I need to add 6. And if you notice, we're doing the same thing to both sides, both inequalities. -14 plus 6 is -8. 14 plus 6 is 20. To get the x by itself, I have to divide by 4. So I get x is less than -2, or x is greater than 5. So both of those are in order right now, from least to greatest. So I can just say, yep, there's my answer. But now we need to graph it, okay? So I'm going to put 0 in the middle somewhere. I got 1, 2, 3. I'm just going to move it over a little bit. I'm sorry. 1, 2, 3, 4, 5, because I want you to see 5. And then -1, -2, -3. So at -2, I am open. It's less than, so I shade to the left. At 5, we are open and it's greater, so I shade to the right. Writing this in interval notation, our graph begins at -infinity to -2 where it's open. There's a break, and then we pick back up at 5 and it goes to +infinity. And hopefully you remember that, because I just did the same thing on the other side with one of our graphs. Okay, so -infinity to -2, open, union, 5 to +infinity. And that's it, guys. And I got 100%. So if you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Your test is coming up, guys. It's only a day or two away. All right? So this is Mr. Grice signing off for Algebra 2, Unit 3, Review A, Video 2. Thanks for watching.